So this is rational zero theorem. What's it mean to be rational? It doesn't mean be quiet. No, rational is any number in the form A over B. That's all it is. Any number in the form A over B. Examples would be things like -1, 5, 2/5, -1/3. Because even numbers like 1 and 5 are rational because you're sitting over a 1. So you got all your whole numbers, your negatives, and you got any fractions. And to some degree, you have some decimals, like maybe 2/10. Is 2/10 a decimal that could be represented perfectly as a fraction? So you got anything like that. So any number in the form A over B. And this is rational zero theorem, so it finds rational zeros. Or at least it gives you a list. For any polynomial f of x, every rational zero has the following form. You ain't got to write all the text off to the side, but you should definitely write this down. P over Q, which is factors of the constant divided by factors of A. Constant's the back of the bus and A is the front of the bus, kids. And it finds real zeros like 1, 2, and fractions. It doesn't find weird zeros. Doesn't find things like √3, which is real. Doesn't find imaginary stuff. It just finds rational zeros. That's all it finds. And I've got a worked out example up here. It says, for example, 3x squared minus 10x minus 8, where p is 8, the last number, and q is 3, the first number, has potential zeros or potential roots at the factors of 8, which is 1, 2, 4, and 8, over the factors of 3, 1, and 3. And what I've done down here at the bottom is I've gone through and I've done the division. I've taken 1, 2, 4, and 8, and I've divided by a 1, so they repeated. Then I've taken 1, 2, 4, and 8, and divided by a 3, and created those fractions. So if this thing has a rational zero, it's in that list. If it has a rational zero, it lies in that list, okay? The next thing we do in your notes, there's a question just like it on your test Monday, different numbers obviously, but usually you see one show up on the end of course exam. It's an easy question. 90% of all students miss it, but it's an easy question. It's not meant to be missed, but it will be, because the end of course test is in what, April? That's a long ways away. Find all possible rational zeros of 25x to the fifth plus 3x squared minus 7x plus 9. You do this by doing factors of the constant over factors of A. So what's the constant? 9. So we do factors of 9. Sitting over the factors of A. 25. A is always found in the front. It's first constant coefficient you run across. Over the factors of 25. And it's commonplace to write out your factors in increasing order, which is something I think that gets a lot of kids. A lot of kids can't multiply and divide to save their life. Factors of 9 written in increasing order. That's right, Alex. 1, 3, and 9. Not a hard one. You're not. Anybody besides Alex tell me the factors of 25 written in increasing order? 1's always the first one, by the way.
Plus or minus 1.
You don't know what to do, write down plus or minus 1.
Plus or minus 5.
Plus or minus 5. And then 25, because 1 times 25. 25. I write out the full list. I'm not going to leave this. Nobody's going to leave you that as answer to this. Nobody. It's going to be multiple choice for sure. But your list is where you go through and you do the division. So first you go through and you divide everything by 1. You take 1, 3, and 9 and divide it by 1, you get 1, 3, and 9, right? Plus or minus 1, plus or minus 3, plus or minus 9. Then you throw away the 1, because you're done with it. What's the next logical thing to divide everything by? 5. You'll introduce your fractions here. Plus or minus a fifth, plus or minus 3/5, plus or minus 9/5. Anybody have any question where those 6 terms came from? I said 6 because plus or minus symbol. Everybody okay on that? What's the next thing to divide by? 25. That'll give you a 25th, 3 25ths, and 9 25ths. So if this thing has a rational 0, it's in that list. And that's a big deal. It's an if it has. It's in that list. That's all it is, potential. All right? Just potential. Any questions on that? Again, there's one like this on your test coming up. It's not hard. That's exactly how hard it is. It ought to be 5 points for everybody. We'll see. Find zeros using synthetic division. Find all real zeros of f of x equals x cubed minus 4x squared minus 15x plus 18. And I've got your goal there in that little circular rectangle. The general idea is to use synthetic division until you're down to a quadratic, at which point you can factor or use a quadratic formula. Man, my second and fourth period classes today couldn't tell me what a quadratic was. Quadratic is x to what power? Second. Aggravates the living crap out of me. How long we been talking about x to the second? A long, long time. A quadratic is x to the second. If you don't know that a quadratic is x to the second, what makes you think you deserve to pass? Because you sure don't. Not at this point in the game. How many zeros do I need to pull from x cubed to become x to the second? 1. So I need to pull 1. I need to pull 1 0 or factor, however you want to think about it, from x to the third to be able to factor or QF. There was a lesson Thursday when I wasn't here that I had pre-recorded. And in that lesson I talked about remainder theorem, which is the prereq for this. Because I'm going to teach you an easier way than Miss Buckley taught me once upon a time. She made us do this the hard way. She'll even tell you she made us do it the hard way. Remainder theorem. You might remember it from Thursday's lesson pre-recorded. That doesn't surprise me. Remainder theorem says if f of some constant is 0, then x minus the constant is a factor. That's a big deal. Hopefully that f of c doesn't throw you off. Means you let x be a number, and if you get a 0, so be it. So what remainder theorem is telling us we can do is we can plug in numbers until we find a 0. So I'm going to plug in some numbers until I find a 0, and then we will synthetically divide out. To reduce the polynomial to a quadratic. At which point I can use previous knowledge of factoring or quadratic formula and find any remaining zeros that there might be. Sounds like fun, doesn't it? It's not that bad. It's really not. So I guess we'll make a list. We know how to find lists of potential zeros now, don't we? We'll make a list, and then we'll plug crap out of that list into the function until we find a 0. There's a reason most of you all have calculators on your desk, because we're going to use it to do it with the TI-84 for the most part. So let's start with a good old list. Factors of what? We just did it twice. Factors of. I can't just pull numbers out of thin air. I need a list to look at. Factors of. Factors of C over A. What's the constant? Factors of 18. Over factors of what? I think cadence in 1. What's factors of 18 going to be? I agree with 1 and 2. 1, 2, 3, 6, 9, and 18. Over plus or minus 1. And what you have to do is you just have to randomly guess crap. Guess a number that's in that list.
4.
Okay. I don't know if it is or not. I'm tired, man. I've been recovering from sinus infection. I'm going to use the storage feature calculator in case I'm wrong. So we're going to find f of 4. That was a guess. Take a 4, store it where? X. I know a lot of y'all don't like this feature. But you go show this to somebody who's taught math for 20 years and never seen it, they'll be like, ooh, this is nice. Because they actually understand it. It's actually pretty cool. Take a 4, store it to X. Hey, go show it to Buckley if you ever run across her. I'd put money she's not aware of it, unless some former student of mine has shown her. Type in the original function, x cubed minus 4x squared minus 15x plus 18. Sorry, partner. What were we hoping for? 0. You know, we just learned that f of 4 is negative 42, which is definitely not 0. We're looking for zeros. Take another guess. It has to be in that list. Which, by the way, why did you tell me 4? I thought it was 0. 2? Of course that didn't work. It wasn't in the list. The list has all potential zeros. Take a 2, store to X. The nice thing about storage features, you can just press that magical up arrow until you have your equation. Nope. F of 2 is negative 20. We only need to guess 1. Remember that? Keep guessing. 6. I think 6 is 1. 6, stow, X. Up, 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 up. Enter. There we go. F of 6 is a 0. That's cool. F of 6 is 0 tells me that X is 6, and the factor is what? If F of 6 is 0, what's the factor? You look where it says literally that X is 6. To make the factor, you move the 6 left. Right? What's the factor? X minus 6. I know that's been done with y'all. I know it has been. Of course, I also know from years and years of doing this, it's hard for y'all to remember that. But the factor is X minus 6. So let me clear off a whole bunch of room here so I got some room to do stuff, because y'all have more room than I do. So we found that X is 6. The factor was X minus 6. We're doing synthetic division. We have the 2-story, do you remember what this thing is called? Venculum. That's right, it's Latin. What goes out in front of that? 6 or negative 6? 6. It was X equals 6, right? Top floor is coefficients. 1, negative 4, negative 15, 18. What's the acronym? BMA. Which used to also be an ingredient in pre-workouts once upon a time, but they had to quit giving it. Put it in there because kids were having heart attacks. Dimethylene is what it is. Dimethylene. Emphasis on the meth. Because I used to take those pre-workouts in high school. Great shape for that, kids. You drink up one of those old ancient pre-workouts from 7 years ago, and it was like life in HD. Oh, it was great. Good energy for hours. But people started taking those things in the middle of July during football practice and dying, so they banned it. Drop the one, and after you drop, what do? Multiply. 6 times 1 is 6, and after you multiply, add. That's what the A is for. Okay? Billy Grace, the M is for multiply, the A is for add. Drop, multiply, and add. Now gives us 2, we multiply and get a 12. We add, we get a negative 3, we multiply and get a negative 18. There's your 0. That was expected, wasn't it? We knew it was a 0. We were supposed to have a remainder of 0. Speaking of which, that's my remainder. What precedes a remainder, Harley? A constant. Reasia, what precedes a constant? An x. Milo, what precedes an x? X squared. All right, here's what we've done. We have synthetically divided out the factor x minus 6. And when we divided x minus 6 out, what was left as the quotient? Because that is the quotient down there.
X squared plus 2x minus 3.
By the way, the goal was to find zeros, so equal to 0. Now that you've reduced to a quadratic, if you'll go back and look at that little note that I typed up, it says the goal was to reduce to a quadratic, at which point you can factor or quadratic formula. Factoring is fast. There are factors of negative 3 that add 2. A lot of teachers actually just tell kids to do quadratic formula. I mean, a lot of teachers do. I'm not one of them. Create an x squared takes an x and x, kids. Factors of negative 3 that add positive 2. 1 and 3. The 3 is positive, the 1 is negative, because last I checked, 3 minus 1 was 2. Then you get to use the zero product property. First factor you already know, x minus 6, x is 6. We did that one, right? The second factor, x minus 1 is 0. The reason I'm doing this, and I shouldn't have to do this, is because on the last basics quiz, 60% of my students can't use zero product property. Bad. If x minus 1 is 0, what's the x value? 1. X plus 3 is 0. What's the x value? 1, 0, 2, 0, 3, 0. X cubed. Pay attention to that pattern. Whatever there is as an exponent is how many zeros you're going to have, kids. That's called the fundamental theorem of algebra. So that was an easy one. My guess is the next one not so easy. Oh, look at that last number. 42. Look at that first number, 2. There's a buttload of factors of 42. 42 is only how many bushels are on a buttload. I don't know if you noticed that on your formulas or not. Need factors of 42. That is an actual legit form of measurement, by the way. For those of you who have no idea what I'm talking about, you should look at the formulas. Buttload is a unit of measurement. Factors of 42 over factors of what? Of 2. All of you. Got a fever? Oh, you should have moved it back to class. I don't care. If you got a mid-range fever, you move it back to class. Do I need to get you a mask? Because I still have them. I'd have moved it back to class. You have a mid-range fever. You are contagious, Nathan. I'm not doing it. I understand. Maybe you just have a sinus infection like I did. I hope so. I had the flu when I had a fever, and then I had a sinus infection. Huh? You got tonsillitis. You got ice cream. Did you get them removed? Factors of 42 in increasing order.
Negative 1.
Start with 1. If you don't know anything, start with 1. Given. 2. 3. 6. 7. Everybody gets to start using symmetry, by the way. That's the middle. 6 times 7 is 42. 3 times what? 14. I don't know if maybe you see the symmetry or not that I'm talking about. 2 times what? 21. And then 1 times 42. Down low, what do you got? A lot of kids don't like to write this out. They like to jump straight to the answer. And, you know, that's why most kids miss it. You know, that takes forever, doesn't it? It doesn't. Time to make a list. What do you divide everything by? 1. That's just repetition. Now what do you divide everything by? So you'll do plus or minus a half, and then you'll do 2 over 2, which is what? Does it make sense to put that in the list twice? Don't. Don't put anything in the list twice. The new ones are going to be a half, 3 halves, 7 halves, and 21 halves. Because anything else is going to be something that was already in that list. Now we get to do a bunch of guessing. We want to guess until we run across what? Zeros. By the way, how many zeros do I need to know? Not 1, not 4. No. Eventually I have to reduce to, let me rephrase this, to reduce to a quadratic so that I can factor or QF. How many zeros do I need to know? 2. That's 2x to the 4th. I need to know 2 zeros. Because 4 minus 2 is 2. I need to know 2. So I need to guess. And again, use the storage feature. If you don't like this, I can teach you the way Miss Buckley did. Miss Buckley taught me to guess and synthetically divide. I hope I get a what? A 0. And if I was wrong, do it again. Guess, synthetically divide. Guess, synthetically divide. Guess, synthetically divide. That's the long way of doing it. You have remainder theorem at your disposal. All right? So don't act like this is hard work. This is the easiest way in our teaching. So what do you want your first guess to be? 3? 3 store x. You need to learn how to use the storage feature. Of course, you have to type in that polynomial. 2x to the 4th plus 5x to the 3rd. Sorry, I got 120. Need another guess. 7 stow x. And then remember, you can press the up arrow, right? Nice thing about storage feature, you don't have to retype. You just have to not make a mistake the first time. Sorry, it's 5,544. Well, why not? 3 over 2 stored to x. I think Nathan might have found one for us. My memory serves me right. He did. Good job, Nathan. F of 3 halves is 0. By the way, if f of 3 halves is 0, what's the factor? That's right. That's the factor x minus 3 over 2. You don't feel good, but just pay attention. Good. I'm sorry you don't feel good. I moved you back to class because you have to understand it, right? Nope, I don't. That Grace been out for 2 weeks. All right, we need how many more? 1. Keep making guesses, kids. Pick a number out of your rear end. Just guess. 21. 21 is in the list. That's a big number. Pretty far from 0. Huh? I have the advantage of having. You watched me. I have the advantage of having done this a couple of times. It's -2. That's the other one. Okay. Now, you remember what I was telling you about how I do this? It was synthetic division repetitively. Can you imagine how much longer that took? It took a lot longer, and it took a lot of paper, right? So I don't want to hear that entitled attitude that this is a lot of work, because that is an entitled attitude. This is not a lot of work. I know that f of -2 is a 0, so what's the other factor I'm now aware of? I'm aware of x plus 2 as a factor. Now, I could do long division if I really wanted to, but I don't want to. That's what synthetic division is for. Long division is long, and I don't need to. Long division is only useful when you're dividing by something like x squared. That's the only time you do long division. All other times you can do synthetic. So I'm going to count on y'all to remember those factors. They were 3/2 and -2, weren't they? Which one do you want to divide out first, 3/2 or -2? Yeah, the fraction is the issue. And when you do synthetic division once, you reduce it on down, don't you? So do the easiest number first, which is the -2, outside your vinculum. 2, 5. Do you need placeholders on this one? None of the examples and notes have placeholders. Don't forget about the idea of placeholder. You have a jump between exponents, you need a placeholder, and you drop, and you multiply. And after you multiply, you do what? Add. And after you add, you multiply. Then you add. Then you multiply. Then you add. And then you multiply. And if you don't get a 0, you know you screwed up. Right? Because it was a 0. Some people will do a brand new problem off to the side, but you can just keep using what you got. What needs to be divided out this time? 3/2. Oh, lordy, it's a fraction. 3/2 times 2, what do the 2's do? They cancel, that's 3. 1 and 3 makes 4. 3 times 4 is 12, sitting over 2, what do you get? 6. -20 and 6 makes -14. That's 3/2 times a -14. 14 over 2 is 7. Isn't it? So 3 times a -7? Of course it was -21. You didn't even have to know what it was going to be, did you? It had to be -21. All right, here's what we got. We factored out x plus 2. We factored out x minus 3/2. And what are we left with? Look back at your notes. Remainder, constant, x squared. What are you left with? I'm good with that. Milbrath's first commandment of math is if you can pull it, pull it. Why it's the first commandment of math? Because it's so important. That last factor, 2x squared plus 4x minus 14, all 3 pieces contain what? A 2, and it can be pulled. I'm actually going to put it in front of the factor where it actually should be put into. You know which factor that 2 should be put into? Not the first one. The way I wrote it, the second one. Because that thing's got a fraction. And if you double everything, it won't have a fraction anymore. But anyways, that doesn't even matter on this example. The goal here is actually to find zeros, not necessarily factor. We already know this 0. That was -2. We know this 0. That was 3/2. There's 2 more there. And again, if you go back and look at that circular rectangle, it says you got 2 choices, factor or QF. Will x squared plus 2x minus 7 factor? No, there are no factors of -7 that get you to 2. So what do you got to do? You got to sing x equals -b plus or minus square root b squared minus 4ac all over 2a. Or not sing. Whatever. You can choose not to learn it. This is also the reason I pulled the 2. I made all the numbers small. What would opposite B be? -2 plus or minus square root. What are we supposed to do that be? Square it. That's right, though. Over 2 times 1. I don't want to just say 2. There's some kids that always think it's over 2. Because in Algebra 1, which you can do in Algebra 1, Algebra 1, everything is about x squared. All right, what's in the radical?
Two.
32 is right. Now both pieces are over 2. I went ahead and broke it apart. What's a -2 over 2? -1. Something, and you'll see this tomorrow, something that got a lot of you on the basics quizzes was you don't simplify. You forgot to simplify. You're supposed to simplify. You've got root 32 over 2. Simplify the radical. What are factors 32? So that's root 16 times 2 over 2. And what's root of 16?
4.
That's 4 root 2 over 2, which is 2 root 2. I think a lot of kids see all the work that we do on paper and think it's a lot. You're supposed to do most of that up here. You just see in a math teacher show you all the steps is what you're seeing. You're supposed to do a lot of that up here. Okay? So it turns out root 32 over 2 reduces down to just 2 root 2. Which, by the way, those 2 answers are weird. They're real, but they're weird. They're irrational. Were they in the list? Of course not. That was a rational root theorem, not an irrational root theorem. Anyways, you got 2 answers there. 2 you found. It was x to the 4th. You found all 4 zeros. And that's a good stopping point. I don't know if there's another slide in your notes or not. That's a good stopping point. Farther than I got in 4th. Yeah, if you want that 49 points for homework, that thing is due Monday.